Well, hello. How's everyone doing tonight? Got a lot of people here tonight. Let's see. We have a few things going on. We have our votes going on Twitch and on YouTube, so you can vote for which system you want me to work on. Hello on Twitch. Hello. And then I got a kind of a cool surprise here is we have a motherboard that was sent in, and DIY Dave was working on this board, and so he sent it in to me so we can actually take a look together and see if we can get this figured out too. So we're gonna look at this one, and we'll look at those systems that we have put a vote up for. So the three systems that are up for grabs, the first one is an M15R2. The customer is working on it. He said he changed the battery in the DC jack. And then he did something, and then it I don't know, he shorted something out, he heard a pop, and saw smoke. So probably not, I don't know. We'll see. We'll see if we can fix that one. The Inspiron is, usually I don't work on Inspirons because they're not worth that much money, but this motherboard's actually kind of an expensive motherboard, kind of hard to get. So, hey David, thanks for the donation. Any donations going to the stream are going to go to these repairs, by the way, so I don't keep any of that. So the Inspiron says no power at all. So yeah, we'll see what happens there. It may just be a bad charge controller or something like that. And then the last one's an interesting one. So if you guys don't vote for this, I'm going to end up probably doing a video on it. It's a G series laptop, 7590. And the fans aren't detected. So they basically keep saying the fans are not there, and when you do BIOS updates, they try to do everything to try to make the fans work no matter what. So I'm assuming that the fan power rail is missing, something like that. So it might be something interesting to find. So, but anyway, cast your votes on Twitch and on YouTube, and we'll see if we can get this stuff figured out. But in the meantime, I was going to kind of mess around with this board that was sent in by good old DIY Dave, our moderator. But let's say hello to everyone. So we got Australia, Guyana, let's see where else, Canada, Vancouver, the UK, Oregon. Shout it out here. The Czech Republic, Hawaii, Africa, Kenya, nice. Very nice. Boston. Got in Ontario again, Kentucky, Atlanta, Arizona, Montana, or Missouri, Tampa, Florida, Texas. All right. Yeah, so I hope everyone had a good Labor Day. If you're in the United States, we had a Labor Day holiday on Monday, which is, it's just you take the day off from work, but you end up doing other stuff anyway that seemed like I was at work anyway, so I don't know. Let's see. Oh, Sweden is here too. Wow. Wow, they're all over the world. So, so while y'all are voting, cast your votes, and then we are going to, while you're doing that, I was just going to take a quick look at this here, this board. And DIY Dave sent this in. Where's his paperwork here? He sent a huge book here, and a book to read. So he tried a bunch of different things, and so he's just trying to figure out exactly, and I haven't looked this yet, so I don't know. We're going to kind of wing it here. I see that we do have some issues on the board there, but let's get on the microscope and just do a quick sweep around while y'all are voting, and that way we can kind of figure out what's going on here. All right, so over here we have some fun stuff going on. What is that? So it looks like we have an exploded component next to a resistor. So a 100 ohm resistor, and then some sort of exploded component, which is probably like a diode or something like that, a double diode. It says PD, so power diode. So it's probably a double diode of some sort. It's funny, it's like, I have tons of donor boards, and I probably have a donor board for this, but because I don't ever work on Inspirons, I just kind of toss all the Inspiron boards, but we'll see if I can find something that will get us close. Dave, did you want to call in and have a conversation so everyone can hear it? Because then you can kind of explain what you've been doing on this. You know, that's if you want to do that. I can send you an email with the phone number if you want to do that. But yeah, so I see this here. That's what the first thing I noticed. Let's see, and I will look around over here. We see some like burnt marks there. Looks like a little arcing explosion under that. So, but that almost looks like something kind of touched there, but I don't know. I'm glad to. Okay, Dave, let me send you the phone number and my extension, and you can just call me on my work line here. Let me send you that real quick. Give me a moment, sorry. All right. All right, so I sent that off, Dave, so give me a call, and we can get you on the call, and you can kind of help explain exactly what you've been doing. Let me grab my phone. And so far, if y'all just want an update of what we have on our votes, 65% of the people are voting for the pop and smoke. And then we have a dead tie for second place for the other two at 17%. And then let me see what we have going on. Fans don't spin. So on Twitch, there's 100% votes for fans don't spin. So Twitch is a little bit on the, we only have 8 viewers over there. So hopefully that will pick up and we'll get some more votes on that side. But a lot of people want to see that. So that will be second place for sure. But I'm going to keep looking around this board until Dave calls. And all right, so, and here he is. Dave, how's it going?
It's going just fine, sir. How are you doing, Nathan?
All right. Everyone's very interested to know exactly what you've been doing on this board and all the work that you've done to it. And so if you can kind of explain, and hopefully everyone can hear you.
Here's what happened. I was doing actually it was the case on the thing had broken, the bezel around the screen. I was just doing a bezel replacement. Had taken it all apart, put it all back together, getting ready to power it back up, and it wouldn't power back on. It was just dead.
Okay.
I took the board out, and I did not inject any voltage to it. All I did was start checking power rail. First thing I checked for was a shorted main 19-volt power rail, and there were no shorts. At least I didn't see any shorts initially. And I noticed the intercell, the battery management chip, that resistor right there, I will confess, that's my terrible soldering job. And that intercell chip were both dead. So I replaced the intercell chip and did a better job soldering it than the diode there below it. It looked exploded to me, but when I tested it, it still worked, so I didn't try to replace that.
Oh, okay.
But beyond that, what I did find was on what I believe is the power rail to the CPU, the second MOSFET appeared to be shorted. And then when I measured resistance from that coil to ground, it was like 2.4 ohms. And and this may be where I messed up, that may be where I messed up, in that I thought that probably indicated that the CPU was shorted, and that's when I stopped.
Right. And so, common misconception is that the CPU will have, that's too low of resistance, but on a CPU, you're going to be around 1.5 to 4 ohms, depending upon how powerful the CPU is, and if it's a GPU, you're going to be under an ohm usually. So I think that will measure fine. So we can kind of look around that. And so, I think, so you've already replaced this, right, the 95522H, so you put a new one of those on there.
And it's a brand new one. I ordered it off on Mount.
Okay, perfect. And then this one, let's see if this is measuring okay. And we're getting 10 ohms on that, so that's correct. Although it should be 100, right? Or is that, no, it's just 10, because it's 10 with 1 0, yeah. Yeah, and then in diode mode, you said you've already tested this to make sure that this is working properly?
Yeah. When I replaced that, I did put that under a thermal camera when I had the power adapter on it, and those things were, that resistor that feeds pin 17 on the intercell chip, that and the inner chip are both glowing red hot.
Gotcha. Well, if I measure this way, I'm getting a short across here, and if I measure this way, I'm not getting anything, which is perfect. If I flip my probes, I'm getting a beep, which is perfect here, and then I'm still shorted on this side. So this side is actually shorted across.
Okay.
So that definitely needs to be replaced.
Okay, then I screwed up on that one. Then.
Or blew out, you know. But I mean, seeing how it's damaged anyway, it probably needs to be replaced. So, okay, cool. Well, let's look around here. I think I grabbed a DC jack and kind of put it on here. I can't remember if I don't even know if this is the right one. It did plug in, so we'll have to test to make sure that I've got the right DC jack to plug in there. And then this MOSFET near the CPU. This is the one that you were saying is measuring shorted. Let me see if I can zoom out so you can see which one I'm talking about.
Diagram. It's kind of zoomed in.
Yeah. Yeah. So let's look at your picture here. So we have. Let's see what we have here.
Yeah, I put a note on the one that I put that one there on the bottom there, well, on the left. That was that second MOSFET right there. That I circled. That was the one that I noticed had the short on it. Yeah.
Okay. All right. And then this one's the one that's burnt. If I look at that one, it's burnt. So, yeah, we'll look at these two. Okay, perfect. All right. Thanks, Dave. So we'll do that while everyone's voting, and maybe we'll get it figured out, or maybe we won't. Who knows, right? This is all part of the adventure. Well, thanks for calling in, Dave. Appreciate it.
Well, thank you, sir. I appreciate it, Nathan.
All right. Bye.
Thanks very much. Bye-bye.
Bye. All right, well, there you go. We got our legendary DIY Dave, our mod, has just called in, so he explained everything that's going on here. So let's see. I want to pull that diode off real quick. And I see JFix saying floating resistor on MOSFET leg, possibly. We talking about the MOSFET over yonder on this burnt one, or which one are we talking about? Let me measure these real quick just to ground and just see what we got going on. So this is, I'm in diode mode right now. I just want to measure to see what these coils are saying. Actually, I'm going to go in resistance. All right, we got 2.2 on this one. Oh, hey, I'm gonna make it where you guys can switch this for me, so I don't have to do anything. Sorry about that, guys. Oh, I'm getting, it's hard for me to keep up with the cameras at the same time. I'm going to zoom out just a little bit so you guys can see better, but we're just going to look at these. All right, 2.6, that's fine. That's for the CPU. This one should be the same, 2.6, 2.4, and then this one should be the same here. Oh, 1. So this must be the main one that actually powers the CPU or the boost circuit or whatever the higher end. Or it goes to something else altogether, actually. What is that? What does that go to? See, we don't know what these things go to. But these are paired together. These are paired together. But this one does not have a pair of MOSFETs to go with it. So we could have a short over here even. But I want to clean up this area first before we even kind of mess with anything. I mean, it seems like we should do that. Before we should try to guess what's going on the CPU side. So let me fix that diode. We'll have to find one on another board. We'll see if we can seat that resistor down better. Get some air going. Where are my tweezers? And so, again, I don't work on that many Inspiron, so I don't have tons of knowledge on these, just because I just don't even mess with them because they're not even worth it. And to be honest, this board is not very expensive, so people are going to ask, is it worth it? And it probably isn't, but this is just all for fun, all for entertainment. Look how nice that just sat down there. Let me get rid of some of that extra solder. Do you have a hot air station there, Dave? Because this chip got put on there very nicely, so I'm wondering how this one's all blobbed out. Oh, and I did get some of that Northridge Fix flux, if y'all want to see what it does. Let me show you what it does. And you can see I'm not actually using it right now because I kept trying to use it all day and I gave up. So if y'all are if y'all haven't seen the video yet, so Northridge Fix just came out with their new NF flux, and he's, you know, raving about it. So here it is, NF flux. I wrote down on it because it comes in a syringe without a label on it. So NF flux right here. So here's his NF flux. Comes out, and he says it doesn't have any smell. I can tell you what it smells like. It smells like lotion to me. It smells weird. It smells like lotion. But watch this. So I'm going to blow on it, and it kind of just goes away. I mean, I have a higher air pressure, but yeah, that's what I always use. So now it's like running all over the board. I mean, it works okay, I guess, but it smells weird. All right, let me take this off. Okay, so we got that guy off of there. So anyway, we'll play around with it. I have both. This is Amtech 559. We got NF flux, and then I have the stuff I actually like to use is the Amtech 213. So that's what we're going to use. Let me see if I can find. That'd be cool if I have a donor board just sitting around like this. I'm going to switch over here. We're going to go digging in my donor board pile over here. My Inspiron piles are down here somewhere. These are the boards I don't generally use that often. A lot of these are gaming laptops, gaming boards. Well, yeah, I don't see the exact board over here, the exact same one. I mean, we'll be able to find something off of one of these. And then let me dig in my motherboard scrap bin because I usually will throw those out pretty quickly. Well, I don't see any that look like that. I have tons of motherboards in here. Here's just another Inspiron board. So these are kind of, I don't know how close these boards are, but so here's his board, and here is the other boards I just found. Totally different shapes, but we might be able to pull some components off of it that's pretty close. So let's see. I'm not doing good reading chat tonight. I'm sorry. I'm just kind of preoccupied with doing this other thing here, so maybe that wasn't the best idea to try to multitask and do that. I'm gonna, let's check our votes. We're at 300 votes. We got 500 people viewing, and we're at 63% pop and smoke. And then let's check out the, what was the vote on Twitch? Well, I don't know where the results went. Where'd the results go? Huh. I don't know Twitch well enough, but I think Pop and Smoke won over there. So, so we are going to be probably working on that Pop and Smoke first, and then we're going to be working on the Fans Don't Spin next because of Twitch, right? So, but let's see if I could find one of these diodes. We just need a double diode. Here, double diode, where are you? Are you a double diode? We don't know. I'm going to go near a power management chip. You're twitching? Yeah, I have 15 viewers on Twitch. I'm pretty proud of that. I just opened my Twitch account last week, so I haven't done any Twitch streaming. So last week was our first time, our maiden voyage, and that looks like it's a PQ, PD. Let's see if that guy's good. Diode mode. It says PD right here. We're assuming that this is a double diode. If it goes that way. Come on. So that way. But we don't know which direction it is. Okay. I don't know why that one's not triggering that way. It's a transistor, so I just turned it on. See, it's shorted that way. Was the other one a transistor too? It says PQ, so the PQ must go to that, not the PD. Oh, yeah, that's a PQ. Yeah, I know. Well, I saw the. See, the thing is, I saw this PD here, and I was thinking it was going to be a double diode, but you're right. I know the PQ is right next to it, so we're going to keep hunting. But you see how I figured out it was a transistor pretty quick whenever I actually triggered that leg and it turned the thing on. What we got here? If we have the exact board, it's so much easier. There's our broken one. PQ. I should have been better prepared. I thought about actually being really prepared, but then I thought I could just wing it. And having the donor board would have been nice. So I don't know if we're going to be able to find one of these things. PQ. Let me go back to this board. Let me make sure that it is a double diode, right, and not a transistor. It says PD right here, so B01. So we know that we need it. Oh yeah, someone have it? Someone have a schematics for it? Here's the schematics. I mean, schematics aren't going to help me find the part on a different board though. It's an LAK032P. But it's not going to help me find it on a different board, I can tell you that. So this is kind of boring, just hunting around here. I'm already losing interest myself, personally, trying to find the part. So, you know, do we need the double diode to continue? I don't know. Let me make sure this DC jack I plugged in here is right, because we can actually play around with. I just need to make sure that it's not, the polarity is not backwards just because it plugged in. So, this is ground. So that side's ground, that side's plus, and we have that correct, and then I'm assuming that's going to be our PSID line. Okay, I'm going to plug it in. Let's plug it in. Plug it in. So this one takes a small barrel jack. We're going to do it without that, darn diode in there, double diode. And I'm going to put it right here so we can watch for magic smoke. And actually, we'll put the thermal camera up too while we're at it, right? So thermal camera's up. It's not on yet. You can see kind of some reflections. I'm going to tilt the board. So the what is that? The power management chip looks like it's lit up, but it's not. So I may need to change the angle here. Try to get it in a better angle so it doesn't reflect. Yeah, it's kind of looking like it's reflecting. All right, ready? I'm going to plug it in. 3, 2, 1. Okay, we got 0, 0, 0, 0. So our current draw is 0, and then we didn't see anything heat up. I'm going to put just measure the board. So we should have 20 volts coming to here. We don't. So no 20 volts coming even to the power management chip. That's interesting. Was it coming through the double diode then? Let's see. We had 20 volts here. Yeah, so it must be passing through there. Yeah, look at that. You can see it. So if we look closely here, you can see that it was probably working because this is 20 volts right here at this point. Trying to get in focus. Sorry about that. So this is 20 volts right here. And then the diode was sending it through here, and then that was powering the chip. So now we don't have our 20 volts coming across here. So that double diode is actually, just because it was shorted on, it was actually working. So, so we just put it back on. Or we can just do a properly calibrated wire. Let's just do that. Or a fuse. We can put a fuse across it. Yeah, let's do that. I don't know if I have a... Is this fuse too tiny? See if I have a bigger fuse. These fuses are... These are baby fuses. Let's see if I can get a bigger fuse. Oh, here's a nice size fuse. Yeah, that would work perfectly. Properly calibrated fuse. Now, we're just doing this just to test, right? So, I mean, I could put that other diode back on, assuming that because it just was shorted anyway, but we'll put that on there in case it has some sort of catastrophic failure. It will just blow that out. This thing is huge. Look how big that thing is. So I don't want it to touch this other pin over here. We're just going to jump across those two. And let's go ahead and I'm going to put some fresh solder on there. And we'll save another laptop. We'll save another laptop! Yeah. Maybe. But I think, I don't know how long we want to work on this. I was just going to mess with it quickly, and then now I feel like we're going down a rabbit hole. We may need to bench it. What do I do with that? Bench it for one of these Alienwares. All right. It'd be funny if it just turns on after this. Come on. Now, I don't know where the diode is going on the other side. I don't know, and I don't care. All right. It's on there. Beautiful. Properly calibrated. So now we can measure here. We'll plug in the power. Should we get under the thermal camera? Although it's really hot now. So look at all that heat. Yes. Sorry about that noise. That resistor is measuring 10 because it's 10, or it's so 10, and then with no zeros. So that's 10. Okay, so I'm going to put my probe here. You can't see that. Let me put you on this screen. There we go. So you can kind of see both. So I'm going to put my probe right here. I'm going to measure while I plug it in. We have 20 volts and no current draw still, if you notice on the power meter. But we are getting the 20 volts to the ISL chip. And then are we getting our 5 volt VDD? I think that's how this one is, right? Did we get 5 volts on that second pin there? Yeah, 101 would be 100. So now let's look around at some other voltages. We'll go to overhead here. So I'm just going to measure some of the other power rails just to see if anything's present. because we are getting the main power rail, I believe. Or did I just lie? We are getting 20 volts to the ISL chip, but are we getting it to the main power rail? That's a good question. So we should be 20 volts right here too. Or no, 12.6 probably. 3.2. This is going to be the main power rail. 3.2. We have a 3.2 on the main power rail. That's pretty good. So, Ernest, no, this isn't the M15R2 yet. We actually were messing with this board until the boats kind of came in, and but we're about to switch because this is kind of just a side project that DIY Dave sent in, and so we may come back to this. I'm actually going to bench this for right now since we do have our votes in, and looks like most people want to do the pop and smoke, and then we'll probably mess with the other one, which is the Twitch voted for working on the one where the fans were not detected or fans weren't working. So let's, or is that cool? I mean, or should we keep messing with this one? This board isn't even worth a board repair, but we were just going to mess with it for fun, and I'll probably look at it again in a little while whenever we kind of exhaust all of our other things we're looking at. But yeah, the power management chip was replaced, so it could be smoked. I don't know. I did not see the 5-volt VDD coming back out of there, so I don't know if that power management chip got burned up again. I don't know if we need that double diode to be in place. I don't have an exact donor board in front of me, so you know, there's lots of different things that could be going on here, and we're just kind of killing time was what we were trying to do with this thing. So are we good to move on to the M15R2 that had a pop in the smoke? Yeah, okay. I'm going to go ahead and grab that one. And that way we don't confuse people. 15R2, where are you at? Ah, it's in pieces already. Okay. So sometimes I have different, my techs usually look at it first and they'd be like, no, it's board repair, and they send it off to me. Well, it's already in pieces. So I don't know where the burn would be or the pop in the smoke would be, but we're going to have to figure that out. So let's get under there. Let me actually update our title here. Stream title. All right, there we go. So we have an Alienware M15R2. Customer's working on it. He said he replaced the DC jack and replaced, I think the battery was his notes. And then when he put it back together, or when he was messing around with it, here's his notes. He was watching a video on disassembly, because I have videos on how to take apart all these machines. And he had the rear cover and back cover off. He could not get the rear cover back on, and while he was standing to investigate, the rear cover hung up on the motherboard and made contact with a piece of metal on his clothing and shorted out. It was a distinct pop sound and smell of smoke. He stopped there, disconnected the battery, and so that's the condition of this M15R2. Well, what do we think it was? It was on the back, huh? So these rear covers don't really have any metal in them, but what ends up happening, I've seen, is that because all the cables kind of wrap around the back here, I've seen where like the LCD ribbon cable would get snagged here, or something else, probably the LCD is what I'm thinking, but here's this machine. Let me look at the back. We're going to look at his cable and see if it was pinched. Because usually it's going to be one of these cables that kind of wrap around the back, and then when you can't get the door on or the cover on the back of the cover, then it pinches this cable here. So let's see if we can look at it closely under the microscope and see if we see any marks there. Don't know if I'm going to be able to get this close enough. Okay, so what we're looking at, we're just trying to see if it pinched across anything. I don't see it. You would actually see a mark, and if it did cause an explosion, then it would be a lot worse looking than that. Maybe there's a pinch there. And then this other side, there's some more cables. This one, the Wi-Fi antennas aren't going to do anything, and the other one is something. What does it go to? Might go to the, oh, it goes to the Tobii. And I don't think there's much voltage in there, so I'm not sure what would have caused what he described. But let's take a look around his motherboard. Well, we're going to start probably in the back on the top here. So here's where the LCD plugs in. And we're going to be looking for some sort of component that is burned, popped. Maybe I should use the smell test. Ooh, yeah, let's do that. Do we have smell-o-vision I could send out? That'd be interesting if I can give you some smell-o-vision. You know, what's funny is like every laptop smells like someone's house. Well, it just smells like someone's house. That's what it smells like. It doesn't smell like burned. No cat pee. It actually doesn't smell bad. And I'm trying to smell the jack. That doesn't smell like anything. Let me smell the LCD cable. Don't smell anything there. Maybe we'll just do a whole live stream where I smell motherboards and just describe what I'm smelling. That's some ASMR, isn't it? Okay, so I don't smell anything besides someone's house, so that doesn't really tell me anything. I'm not going to be able to learn how this motherboard blew up, but we'll look around. Okay, should we look under this sticky? So LCD connects here. There is the Thunderbolt. That's the USB-C PD controller. That's for the Tobii. And we're just going to be looking at any of these components that are all messed up. This is behind the CPU. This is behind the GPU. Looks okay. This is going to be the this is going to be the RAM. This has memory built on the motherboard. So this actually is like an interposer board-to-board connector. It connects to the daughter boards on the side. So we want to look for a hole in the chip too. There's the power management chip. That's what controls the all of these MOSFETs right here and creates the main power rail, charges the battery. This is going to be the DC jack, the input jack. Voltage is going to come through here, go through these current sense resistors, go through these MOSFETs, and then energize the whole laptop. There's another one of those board-to-board connectors that hook to the daughter board on the side. So far, I'm not seeing any damage. I don't smell anything. So that's a good sign so far. We'll flip it over. Let me take the heatsink off, and that way we can really look underneath it. Oh, am I talking too fast? I'm sorry. That's what the coffee does. And I've been here for almost 12 hours. So I get a little bit, people notice that as the night goes on, I start talking faster and faster because I'm getting more and more delirious. Or I stutter a lot, either one. So I can't get my words out. So pulling the heatsink off so we can take a and I can sing. And I'll sing a song while we're taking apart the motherboard. So, yeah, I am delirious, yeah. Anyway, I'm going to pull the heatsink off. We're going to take a look underneath here, and we can look and see if we see anything messed up. And we can also look at the thermal paste while we're at it. Remember when we're taking off these heat sinks, we don't just lift straight up on there because we can end up damaging the pipe. So we're going to rock it back and forth. So I'm just kind of holding the board and I'm rocking it back and forth. Now that we can see that it's moving, now we can actually lift it up. If you would have just lifted it up, you would end up bending these pipes, and then that damages the heat sink. But most people don't think it damages the heat sink, but it does. And then you'll see it getting hot here, but not hot there. So I will try to slow down. But that is, this doesn't look too bad. So there we go. We have the GPU here. There's the VRAM. Here's the CPU. And here's a regular RAM because it's built on the motherboard. These motherboards end up being more expensive because whenever you have to replace one of these boards, you're buying a motherboard, you're buying a GPU, you're buying a CPU, and you're buying RAM. All in one price point. So even if only one of the components is bad, you'll end up having to replace the entire board and pay for all 3 items, or 4 items, I guess. All right, so let's take a look around on this side of the board. We'll start in this corner. So this is the back of the board, and this would be like where he was trying to plug in, or trying to put that back cover on, and he said it sparked. That's funny. Like, why would this be crooked? Well, the engineers said, you know what, all these are so parallel and symmetrical, we want some feng shui in here, so we're going to put that one a little bit crooked. So that was all part of the plan for the engineers. All right, so these are the power stages for, look, this one has some feng shui too. Look at that. These are the power stages for the CPU. And those all look okay. This is the driver for all those power stages. And let me know if I'm moving too fast, because sometimes I move too fast. And it smears across. And I'm only at 30 frames per second, so not 60. So far, so good. We might be able to try to turn this thing on. But I would expect to usually just see some sort of spark, right? We got some hot glue or some resin. A little harder than hot glue, so it's some resin of some sort. I don't know why, but we'll just keep that happy little resin there. No. Okay, so this is going to be the EC chip. We've dealt with this a lot during live streams and my videos in general, but what an EC chip is an embedded controller. It's like a microcontroller. It runs a loop of code that is actually in charge of starting up the laptop and monitoring for key presses like power buttons, keyboard, things like that. If this thing is burned out, the board will not start. But this is a piece of little gummy sticky, so that's nothing to be worried about. That mark right there may be something, but I think it's okay. This is the BIOS chip for the board. You can see that's a 25Q128, so 128 would be big enough to keep a BIOS on here. A lot of times you'll see these and it'll just be like 80s, which are not very big. They're only 1 meg, but 128 is big enough. All right, so here's our chipset. Chipset looks good. And kind of keep looking around here. Those are the power stages for the GPU. And then our VRAM power supply is right there, I believe. I believe that's what it is. And maybe that one too. See, here's a little 80. So this is going to be the BIOS for the GPU. Okay, well, I don't see anything wrong. This board is working. There's nothing wrong with this board at all. So what should we do? Should we plug it in? Let's see what it does. We'll do it under the thermal camera and make sure. This should get interesting quick. So on this board, do they have a power button on this one? They don't have a power button on here. Oh my gosh. And here's something funny. Every single one of these boards I've worked on, every single one, the person has broken the touchpad connector. And it's because of those engine nerds, right? The people who design these boards. So this is how the motherboard's installed into the laptop, like this, all right, from the bottom. So this is how you access it. All the stuff plugs in over here. There's a couple ribbon cables and stuff here, but the touchpad plugs in underneath. And so whenever you take this out, you end up ripping that because you don't know. So the trick is to actually leave the ribbon cable attached to the motherboard and unhook it from what it's plugged into, so it's just hanging out the back. But anyway, so I've had to replace the latches on those or replace the entire connector on pretty much every single board that somebody has messed with on this particular model. But we're going to have to trigger this thing on. Let's see, do we have a power button? Because a lot of these used to have power buttons built on them, but this one doesn't have a power button right next to the EC chip. So that's where I would like to press it. See if there's sometimes there's a power button over here on this edge. See if we can find one. Aha! Aha! We found it right there. And you can see that someone's been using it to trigger with. So all we need to do is just short those together, and that will be our power on. Okay? We good. We good. All right, so I'm going to plug in the power. Let's do it under the thermal camera, like I promised. So thermal camera is up and running. We're going to plug in the power, and we want to see if anything gets warm. We're also going to pay attention to the power meter and see how much current's being pulled. Because I did not see any damage to the board, and I did not smell any damage to the board. All right, ready? 3, 2, 1. And we got a 0, 0 being pulled. So normally it should jump up to about 0.02-ish. So we're getting nothing at all. Now I haven't pressed the power button, but we should have at least like the, do we have something getting warm? No, those are all reflections. Because there shouldn't be anything getting warm because there's no current being pulled. But if the EC chip's coming on, then we should get that 0.02. Let's just press that power button. Where is it at? I already lost it. Here it is. All right, so we're going to press the power button. Well, we'll keep it on thermal camera. All right, so you can just believe me, I'm pressing it. Ready? There we go. 3, 2, 1. And we got no current draw. So we have some other issue. And so all we need to do now is just figure out how far the current is going. So we're back here at the DC jack where it comes into the motherboard. You can see that this side's the positive. These red, and then that's black. So this is going to be the positive 19 volts coming in, or 20 volts coming in from the charger. And I'm just going to measure it and confirm that we do have 20 volts going there. So there it is, magic. And then that's going to come through, oh, where does it go? It's going to go through these inductors. I'm trying to figure out which way they go. I think it goes through the inductors this way, and then comes out the inductors that way. And then it's going to go out of those inductors into these MOSFETs. All right, so we're just following the voltage. And then it's going to come out of these two MOSFETs, which are in a pair, in parallel, and it should come out here, and it's not coming out here. It's not coming out. So these are turned off. And then once they go through these, it should actually come out of these next ones, okay, and which is not. And then after it's through there, it goes through this current sense resistor, and the current sense resistor is what's being monitored by the power management chip, which is right here. Right there. Right there. Do you guys see that? Let me see if I can change the angle. Nope. Can you see it? Does anyone see it or not? Here, I'm going to change the angle again. We're going to come down this way. See if this works better. I think I see it. Yep. Here we go. Yeah. There's a big crack in it. That's crazy. You see nothing? Look at, do you see the big chunk that's taken out of the middle? The middle of it blew up. So there's a big crack right down the middle. Yeah, canyon. Le Grand Canyon. Yep, you see it. Okay. That's pretty crazy. We missed it at first. We did the sweep, and I was like, yeah, this is the power management chip. I did my regular routine where we kind of go around the board and talk about stuff, right? And, and I did not notice it. because from this angle, you can't even really see it. It kind of blends in, but let me, if I turn it around, let me see if I can see it better this way. Yeah, I can totally see it this way. Totally. Man. Can you see it better that way? Anyway, so we can see what happened now. And we know why the board's not working. There's a big hole there. So what that chip is in charge of, it's actually running all these MOSFETs here. And so we just measured the voltage coming in through the DC jack here and then coming to these MOSFETs, and the MOSFETs were not turning on. And so they're not turning on because the chip that is in charge of turning it on is done blowed up. So we'll just change out that power management chip and hopefully easy lobster dinner. So the question is, do I have more of these? 88739A? I don't even know what that is. I don't think I have those. I'd be surprised if I did have those. Yeah, Bob's your uncle, but we like easy lobster dinner. That's what we go for. Let's see what I got. So is it 739A? Yeah, I don't have one of those. But I do have one of those because I have donor boards. So we'll just grab a donor board. And that will be awesome. So, assuming I haven't stolen all those off all these donor boards. I actually don't have that many M15R2 donor boards. I only have 3. Ah, my favorite one. Locks up when moved. I hate these. Which I've actually been able to fix those recently. There's a locked up when moved situation that's happening, on, not on this model, but just on some models. A lot of times it's the M15R7. Anyway, it's the chipset. And so I just reflow the chipset and that fixes it. But that locks up when moved. This one I already stole parts off of. And let's see, do we have a power management chip? I've already, nope, I have one. Cool. We can take this one. We have it. So let's take a look, see if it's the same number and all that stuff, all that jazz. 88739A. Do you concur? I concur. You should have concurred. All right, so we have the same chip, so we can just swap that out. Hopefully it would fix it up, you know, I don't know. If it's that simple, that would be great. So we're going to start by just removing the old one, the damaged one. We'll take that right off of there, and then we'll just swap it over, and then we'll check the power rails after that. Do we see another issue here? Yeah, maybe. Let me check that. Do you guys see this resistor? Now that could just be a dot on it, but it kind of looks blowed up. Let me measure across there. We're going to measure it in circuit, but we just want to see what it's saying. So in circuit says it's 9 ohms, 8 ohms, 8.5 ohms. Let's see what in circuit says on this one. Now we could get false readings because the power management chip is blown up, but so which one was it? Okay, that one. So we're doing this one. 2 ohms. So I think we should be more at 2 ohms on that. And I think we're measuring 8 ohms. So it can't be correct if we should have 2 ohms there. So we'll probably replace that, I would assume. Assume. Because it does look messed up. So we'll replace the power management chip and that. Now, he could have touched something to this area, and that's what blew this up, and then it blew that up at the same time. So maybe, or even touched these 2 legs together, or whatever it was. Or touched something from the back of the battery to this. I don't know. So let's get those parts, those components removed, and then we will transfer it over. You know what I just realized? I'm doing really bad at keeping up with chat tonight. So, sorry about that. It's hard for me to focus. I am pretty tired, I feel like, actually. But I will do my best to see. So the daughter board resistor looks cracked as well. So this is the bad board. This is the good board. So that is not a crack. That's just kind of how resistors look in general. So what you're looking for when you have a bad resistor is it will have like a dot. You see how this kind of looks like a dot? We kind of say that the resistor is winking at you because it kind of looks like an eye. That's not it. See, I just kind of lightly scratch it, it comes off. Sometimes that's a little splatter of some sticky or something, but I could show you what a burnt resistor looks like. It's just like a hole. It's just like right in the middle. It's just like winking right at you. It's like, we got you. I messed you up. So that's what it looks like, and that's kind of what this one is looking like. Maybe we can wipe off the residue or something and see if we can get it to show its winking eye better. Yeah, there's the winking eye. Hello. Yeah, that thing blowed. Everyone see it? So that's what you're looking for whenever a resistor is blown. And so we'll be able to put a new one of those on there pretty easily. So let's remove those two components. Let's do it. You're learning how to solder. Well, nice. Learning, it just takes practice. All right, so which one should we use? Should we use the NF flux? Should we use my 213 that I like, the Amtech, or the 559 Amtech? We're going to use the NF flux, I guess. Yeah, we're just going to use this all night long, and we'll see how good it is. All right, use the lotion. Yes, it smells like lotion. It smells weird. It does not. It doesn't smell like nothing, like he says it smells like. And it also, I have to keep reapplying it because it runs away. So we'll put a little bit of blob here. Ooh, look how clear it is. And look, it has bubbles in it. He had that as a selling point too. It has bubbles in it. But we will see. Okay, so we're doing 450 degrees C, 60% air. I have my fume extractor on, and I'm just going to try to heat up this area without blowing away all this flux. So if I stay far away, it's kind of sticking there just fine. But right as I get up on it, yeah, it's like running like a river. Look, stay, buddy. I need you. You're my boy, Flux. Stay over here. All right, I'm going to come in a little closer now. I kind of preheated the board from a distance. Coming in a little closer. I'm going to kind of focus on going around the board. Like if you're worried about messing up the chip, you can kind of just heat the area around it more. And what I'm looking for is when the pins start getting shiny, that's when you know it's starting to actually melt. And we want that flux to stay around it. See how I'm kind of moving it and the flux is kind of circling it? So if you kind of work it around, and then you'll start to feel it start getting loose. This is a really thick board, so it's going to take a long time. But you see how now I can actually tap it and it's loose? So now we can just lift it straight up like that. So we have that off. Resistor is going to be a lot easier. So when I heat this right here, I should just be able to grab it really quickly like that. And for the most part, everything should stay stuck to the board with the solder, because you'll use the surface tension of the solder to hold everything in place. So you don't really have to worry about things blowing away. Now, if things are blowing away, it's because it's not actually being held in by the solder. So that would be really the only reason. So a lot of times I'll set it down, I'll tack it in place, I'll move the heat away, let it cool off for a second. Then I'll come back with fresh flux and I'll reheat it and then I'll let that kind of sit where it's going to go. Solder, solder. I can't say solder. I can say solder. No, I can't do it. Anyway, solder. That's how I've always said it. And I think I'm saying it with T's. Solder. I have no idea. It doesn't matter. You guys get the point. I'm also, I live in Texas too, so you're lucky that I don't have like a southern drawl. A southern drawl like Dave's banging. See what I'm saying? I don't have a southern drawl because I'm in Austin, and there's not much southern drawl going on here. All right, so we're going to do the same thing here. Preheat the board a little bit. Trying to make sure that flux gets all the way around. And see, I wish it just didn't blow away already. But, you know, whatever. What can we do? Do we have lag tonight? Oh yeah, I see some drop frames. I see, it says my connection's not that good right now, and it just popped back up. I don't know. I'm having a lot of issues with my provider. Pissing me off. Okay, we're gonna pull this off. I have it right here. And let's grab this resistor too. Got it. And we'll go back over here, right there. I'm gonna go ahead and do the resistor first, just because I have it in my hand. I don't want to set it down. I'm glad to say I have 19 viewers on Twitch. Welcome, viewers. All right, so we have that one in place. Now, this one's not perfect. I don't care about perfect yet. So right now, I'm just gonna kind of tack them in place. So my idea is just to heat it up, set it down, tack it in place, and make sure we got this the right direction. Pin 1's in that corner, I got pin 1 in that corner. So I'm heating these up until all the solder gets shiny. I'm not even replacing the solder. If you noticed, I haven't replaced it because when I'm pulling from a donor board, I'm pulling it off of the other board. So there's gonna be solder on the chip, there's gonna be solder on the board, and then I can just set it right back down on here like this, like that. It's not perfect, I don't care. We will put this beautiful lotion smelling NX flux on here and reflow it. And so if we reflow it, and then now I'm going to tap it, and see now it's sitting where it wants to be. And this one is good too. Oh, those want to fly away though. There we go. So all of that looks beautimous. You want to see from a distance? That looks regulation, doesn't it? Yep. So let's clean it up like nothing happened. So I need a toothbrush. Aha. Toothbrush. And I need some alcohol. And so while the board's warm, I'm going to start cleaning it. Now the issue I did have when I was using this flux earlier is that if the board is excuse me, if the board is cool at all, I cannot clean this flux off. It is like thick and hard. It is a no clean flux, which means leave it all over the board and make it look ugly, but that's not how I operate. So we're going to clean it the best we can, and I kind of just do cycles of rubbing it with a toothbrush and then put this Kim pad over it, brush it, and that kind of picks up the residue. And there we go. Okay, good enough, club. All right, like nothing happened, ish. There's still some flux over here, but we'll finish cleaning in a moment. We just want to see what it does. So, thermal camera again, I guess. I need to cool off the board just a little bit, I think, because it's going to be too hot for it to get all the pictures here. I'll see if maybe I can NF price. Oh my God. No, I'm not saying anything about that. I'm not going to complain about him. I'm just stating that he is a salesman. That's all it is. That's all I'm saying. He's a salesman. He could sell a Cadillac with mud tires, I'm sure. Properly calibrated. Twitch tip. Your current category on Twitch is computer repair shop, which actually is a video game. Oh, really? Is it really? Science and technology. Okay. Yes, thank you. I don't know anything about Twitch. I never go on Twitch. I keep trying to go on Twitch, but every time I don't play video games, and every time I go on there, I'm like, I can't find anything that I can watch besides like chess or something. So definitely thank you for that tip. So I need to change it into science and technology. Boom, I will do that. Okay. I don't know if I can do that on the fly. Maybe I'll do that later. I got 24 viewers though. People are logging in to watch some sort of computer repair shop game, I guess. All right, so, well, this is kind of a game, right? And it's a choose your own adventure because everyone has to vote during this whole thing. So I think we've, well, whatever. I don't know where I'm going with that. Okay, so we are going to plug it in now and see if we have the magic smoke. So this hot area right here is going to be my desk. We can try to cool that off a little bit too. The thing about my OBS stream to Twitch is I have it as a secondary stream. So I'm streaming to YouTube as my primary stream, and so that's actually what OBS thinks I'm streaming on. And then my secondary stream is just piggybacking off of the feed and setting it using my key over to Twitch. So OBS doesn't really even know I have Twitch running, if that makes sense. So I'm using Aiden multi-stream to do that, because then I can just stream to all sorts of different things. It just kind of steals the feed and sends it over. I'm experimenting with it. I don't really know if it's working very well or not, but we are getting some sort of viewers. So, all right, we're going to plug in the board. The board's a little bit warm still, but what we want to look at is the power management, or not the power meter right there. And you ready? 3, 2, 1. 0.01. That's good. 0.02 would have been better, but I can't be picky. And let's measure. I'll just go to the microscope. Or we can go to the mix. There we go. So you can actually see what I'm measuring with the thermal camera. Yeah, I'm going to have to clean this. This still looks really dirty. His stuff gets everywhere. That NF stuff. Okay, so we got 20 volts here. Do we have 20 volts? There we go. 20 volts there. And then we're going to go out of there into this MOSFET and then out of this MOSFET. We have 20 volts coming out of this MOSFET now. Then coming out of those, perfect. Going into the main power rail. Main power rail is up and running. Let's measure our 3 volt and our 5 volt power rails, which should be these guys. We have our 5 volt power rail, and we have our 3.3. So I would say that we are good to go for it to turn on. Yeah, maybe we'll keep it under the thermal camera when we turn it on, and we will just jump that area, which is right here. We're going to use that as our switch. And go. And we got 0.66, 0.13. Okay, turned off for a second, turn back on. And then there we go. CPU is coming on, and the chipset, which is good. Now, I didn't keep it on long enough. I've already unplugged it. I didn't keep it on long enough, but for the GPU to come on, but we can put the heatsink on, and then now we can actually put it back in the machine and see if it actually starts up. So let's do that next. And then I'll say it, all right? But I won't say it until it actually shows a screen. So let me clean off this gunk here, which is so easy to clean. Did you guys see that video that I posted, I think Saturday, with the liquid metal disaster? And if you didn't see it, basically, it was a repair shop that sent it in to me, and the machine was giving a 3.5 error whenever he shipped it off, but whenever I received it, it was actually working. And opened it up, and liquid metal was dumping out of everywhere. So the CPU was overflowed. Whoever worked that day was just liquid metal happy, I guess, or put it on there twice. He's like, oh, did I already put it on here? And he put it on again. I don't know what it was, but it was overflowing, and it was leaking out from around the CPU heatsink and the dam, and it leaked all over the keyboard. It leaked all over everything. So I got that cleaned up and was able to repair the board. Now, a lot of suggestions were like using a vacuum. So I have an idea. All right, I have an idea on how to clean up liquid metal with a vacuum. I was trying to find some sort of miniature vacuum, but my idea is to use like one of these syringes, right? Because I think whenever you get thermal grizzly, it comes in a syringe, and you can actually use that to suck it back up. And I almost bought a tube of thermal grizzly just to dump in the trash can just to use his syringe, which I think is funny. But I have an idea to hook it to. Let's see, where did I put that? Darn it. Here it is. So I have my fume extractor here, and this thing actually has a lot of suction, a lot. So I was going to 3D print a cover that hooks in here, hook it to a hose to it, and then hook that onto a syringe, and then that way I can suck it into this and use my fume extractor as the pump. Now, I don't know if it's going to have a lot of enough, suction, but that would be worth a try. I thought that was kind of interesting. So look for that idea. We may do it on a stream, or I may do it in a video, but I don't know. I don't know. Yeah, I was going to put like maybe a piece of foam or something, but the idea would be to use the syringe as a capsule to catch the stuff. But yeah, if I put something in there, to keep it from flying up the tube, that would be a good idea. I could put just a piece of foam or something even. Yeah, I need a vacuum pump, which I have. I do AC repair at home, and so I actually have like a vacuum pump for AC repair, but that's going to be a lot of, I mean, I don't think I need negative 20 or negative 30 bars or something. Would a solder sucker not work? No. Because it's not solder. That's, it's not solder. So I'm just going to put some Arctic Silver on here. Good old Arctic Silver. We'll do the line in the X method here. You're getting drop frames? I mean, I haven't had that many drop frames tonight, so if you're getting some glitches, hopefully it's only short-lived. Okay, that lined up. You got stuttering, darn it. Is it stuttering for anybody else? Yeah, my Twitch stream says unstable, but it always says unstable. 27 viewers on Twitch now. That's actually pretty good. I mean, maybe my computer's struggling to actually keep up these two streams too. It's an old 10th gen, and I put like a 1050 Ti in it, so it's not very strong GPU. And eventually I will just grab another machine and stick it in there, but it's just what I have sitting around. Audio is fine, but video is stuttering. Well, usually it does pretty well. I mean, but I am getting some drop frames. Right now I don't have any drop frames happening, and it says I have full bandwidth. So hopefully it keeps up. All right, we got to plug these fans in the correct direction. If you plug them in backwards, you blow out the ECU chip. Hooray! But I know which way they go. Nothing to worry about, nothing to see here. So this is what I was talking about, or speaking of, is, so we have a ribbon cable that goes to this MCU board, which goes to the keyboard. And that one plugs in on the top of the motherboard. And then we have this ribbon cable that goes to the touchpad, which plugs in on the bottom of the motherboard, right there, and that's the connector is busted. And this one actually has two touchpad connectors because this board will go into a 17-inch version. If you have it in a 17-inch, it uses this big one, but on the 15, it uses a smaller one. So in order for us to get the touchpad working, we're going to have to replace that connector or at least the latch. So we'll deal with that later. We just want to see the Alienware screen. So we are having a lot of people saying it's just fine. So I'm hoping that the stream stays stable enough for people to enjoy it. And I will probably work on upgrading the computer next week. Every single week I'm doing a little something different. You know what I added this week? I added a second monitor. I had to break out my whole kind of cabinet here and desk, and so now I have a second monitor. Has all my Twitch, has multiple stream chats here. I can talk to multiple people. So that makes it a little bit easier. One step closer. Using Restream to stream could work. If you send it off to Restream, then I want to try to make sure we get the chats working and all that stuff, because I like combining all my chats together. And so you can see on the screen we have both chats on the screen, although that's a secret because Twitch doesn't want that. So don't tell anybody. Shh. Yeah, Twitch is, yeah. They're fine with multi-streaming apparently, as long as you give the same experience. So that's why I'm doing polls on Twitch too, and I'm making sure that we're, giving the same treatment to both. And again, I just started this Twitch last week, so it's interesting to see it kind of already grow. And I will definitely move to the other category and see if that works. Okay, what do we need? Oh, so we need this interposer. And we have both in the same bag. I don't like this. I don't like this at all. No, sir, I don't. So the reason why I'm complaining about this is that these are the two, come on, focus. These are the two daughter boards. We have one on either side. And then there's these board-to-board connectors or interposers that have these tiny little pins, and someone put it in the same bag. We always bag these things separately, so I don't know if this machine was taken apart by the customer or not, or if it was my employee, then I'm not happy. So let's make sure that these things look okay before we start hooking them up. So here they are. We're just going to look closely, make sure we don't have any bent pins. Yeah, that one looks fine. And then we'll look at the other one. That one's a little bent over, but I think it's okay. Whenever they're bent, you really can see they're bent. Yeah, so it's fine. Crisis averted. So I'll just show you how I install one. I'm only going to install one side, actually, because we only need one side in order to power it on. We're going to hook it right here. It sets on just like that and connects these two boards together. The reason why they do this is because this motherboard will fit in a 17-inch machine also, and so they just changed the daughter board out to make it fit into the 17-inch. Why isn't this going into the hole? It's not wanting to sit down in there. There we go. Okay. Yeah, new guy needs to step up. Yeah, new guy's pretty funny. All right, so we'll screw this in place. All right, so we have enough stuff connected, keyboards connected, LCDs connected, and we just need to see if this thing will post now. A moment of truth. All right, so keep an eye on the power meter. Right there. All right, here we go. Okay, so we got 1.29 amps being pulled from the charger, turned back off, which is normal. It should come back on. It's going to go through a whole boot up process, 1.6 amps. And we do have a Alienware head. We got the Alienware backlight on the keyboard lighting up, and we're just waiting for that screen. Waiting for that screen. Did we investigate why the power management chip blew up? Well, the customer said that he touched something to something else and he heard a pop and a burning or smoke or something like that. So that's the cause to me. I don't know. So the machine turned back off, which is not good. So normally it would come back on, stay on, and it's not. I'm going to power it on one more time. Well, we got the 2 amps that time. We got to blink for a second, shuts off. Is it going to come back on? Yes. Okay, that's good. So we're not getting a blink code yet. We are just getting kind of a power on light. 7.3, 7.2. Come on. We need to go up to 2 amps in order for us to get the screen. And we got the Alienware screen. I saved another laptop. There you go. I told you I would say it. So it is up and running. I can boot into diagnostics. And so we were able to save that one. Check that one off the list. So that was a fun one. And I'm glad that it wasn't too much of a pain in the butt. So let me put this stuff away. We can start on another one. Okay, so the next machine, I think Twitch voted on. And so Twitch voted on the laptop, the G series, where the fans don't work. Okay, so that's the next one we're going to go to. So on this machine, we actually had it on our test bench for a while. We tried all sorts of things trying to figure out, like, is it a software thing, firmware? The fans, no matter what you do, you run them in diags or try to run them, they never turn on, and it basically is reporting the fans don't work. And so my thought is that most likely it's going to be some sort of power rail that powers the fans issue. So we're going to have to kind of track that down and figure that out. I haven't fixed this issue before, so it's going to be something where we're just going to figure it out together. And if we fail, we fail, right? I mean, that's, I told them there's only so much we can do, because there's a possibility that's going to be inside the EC chip, and we're going to have to change out the EC chip, or it's going to be something, further down in a complicated area. So let me clean the counter off. I hate whenever there's heatsink compound everywhere. I've got to clean up for the next one. You're asking questions about an M4700 and the EliteBook are the same GPU. I don't know, actually, because I don't work on anything but Dell, so I can't tell you anything about an HP EliteBook. Yeah, you guys keep buying these broken Alienwares from eBay and mailing them to me. I have another one here that somebody sent in. They want to see it on a live stream, and it's a Alienware something, M15R2 or something like that. They bought it on eBay, not working, and they want me to fix it on the live stream. So we will probably do that next week, because we already had kind of a full pallet this week. Let me grab the next laptop. All right, the next contestant is this guy. It's a G Series 7590. All right, new day, new laptop to repair. This time we have a G7590. This is going to be a laptop that the customer said they sent in because the fans don't work. So let's see if we can figure it out. So, so the gist of it is, yeah, I've already told you the gist. The fans don't work. We run diagnostics, and no matter what it does, they don't work. So let's do that just so I can show you. DC jack's way over there. Let me update our title, actually. Give me a second, so I don't confuse people. All right. All right, title updated. Check. All right, so I'm just going to boot into diagnostics. To boot into diagnostics on a Dell or Alienware or any of those machines, you're going to hold down the FN key, hit the power button. That will boot us straight into diagnostics. The other option is to actually hit the F12 button to choose the boot menu, and then you can choose to boot into diagnostics. So we're going to skip out of this. I just want to run the fan tests. So we'll come over here. The fans are saying 0. Let me see if I can zoom in for you guys. The fans say 0. I'm going to run a fan test right here. And the test is running for the video fan. And while that's running, I'm going to get a drink of water. And nothing's happening. So that's it. That's all we're getting here. And there you go. Fans aren't responding. So let me try it again. But I'm going to close the lid and we're going to look at the back. I want to see if the fans are actually spinning or doing anything. The fans are not doing anything at all. So it's not like the fans are even trying to spin and then it's like not registering it's spinning. It's like the fans aren't getting any voltage. So we need to figure out what supplies power to that. I'm just going to unplug the power here. We're just going to exit out of that. We've replaced the fans with new fans. That's not the issue. So it's going to be something in the circuit here that powers the fans, and I have no idea. Haven't messed with this before. So we'll figure it out as we go. Screwdriver. So we'll need to pull this assembly off of here. And we have the blue pipes. Fancy. Did you know if you have blue pipes on your heatsink, it makes it go faster? You've heard that before, right? It's just like a racing strap on your vehicle. It makes it go faster. How does this come out? We've got all these secret screws. So we could test the fans manually, maybe, but we've already put new fans on here, so we know that the fans aren't the issue. Uh-oh, I guess pull that off of there. You think there's something in the water I'm drinking? Oh yeah, there's something in that water. No, I think it's just because I've been here for 12 hours. I get tired. I get delirious quick. All right. So I just want to pull this heatsink off because I want to be able to access, I want to look at this circuit and see if we can find where the fan's power is created. Let's see. So we have our two fan connectors. One here. Oop, where's it at? So here's a fan connector and goes to some of the stuff right there. And then on the other side, another fan connector. Now I don't know what powers it, but maybe it has something to do with that. I don't know why the fans aren't working. Okay, so whoever took this apart had a slip screwdriver, I think, and broke this chip. You see the leg is totally not even attached? Can you guys see this? Is this in focus good enough? Yeah, so there's your sign. There's the problem. Yeah, easy lobster dinner, right? That's gonna be perfect. Yeah, this is an easy pizza actually, I guess it would be, or easy burrito. Can't use easy pizza, we're gonna use easy burrito. So now the question is, do I have a donor board for it? Because then we can just take that component off. 7590, let me see if I can grab one. Let's go back here and grab one. Is this it? There we go. Looks close enough. Looks about the same. A little smaller GPU. Same CPU, same layout. So I believe that is the same thing. So now we can get back down in here and take a look at that component. So what are we looking at right here? It's broken. And then if we come over here, oh, this has a different fan connector. Interesting. GPU fan. And it doesn't even have any of this stuff populated. Huh. So this is a different board layout. You can see that it has this other chip here. So let me grab a different board. All right, so this one has the same connectors on it. So let's look at that again. There we go. There's our guy. So that's the one we're going to transplant. But let's look around and see if we see any other damaged stuff. Since we have slip screwdrivers for days. Because I want you to see this heatsink. So here's the heatsink. No, it's not the heatsink. It was the fan. Is it the fan screws? Yeah. They had to make the fan screws flatheads because I guess they stripped them out so bad. So using a grinding wheel or some sort. So let's try pulling this off. I'm going to leave the board installed, so we're just going to have to protect this area. I'm going to add a piece of silicone behind here, and then we'll put some capped on tape around here. Are we having video and audio issues again? How's the stream over there at Twitch? Is that all looking good? So, I don't know. Here, I'm going to put up a poll, so you guys let me know. All right, so we got 54% say no on YouTube. I only have some drop frames. I don't have tons. Yeah, I can see actually my internet speed just slowed down just now for a second, so I'm assuming it does glitch occasionally. Yeah, it's dropping down again, and it came back up. Quite annoying. So I can try restarting it, if you'd like, without dropping it completely. Yeah, I keep seeing it, I do see it glitching down, like it's, the bit rate is dropping a little bit. So we're 55%, let's see what Twitch is saying. Twitch only has 20% saying that there's an issue, but I am at a lower bit rate on Twitch. All right, so yeah, it's dropping down again, and I mean, I'm wired, so I don't understand why we would have an internet connection, man. I keep having issues with Grande, which is a Sound, which is, it's supposed to be gig, but I'm gonna keep working right now just to kind of get this. Is it bothersome? It's wee bothersome. Yeah, I keep, maybe I could change my bit rate. Maybe I can make the bit rate go down. I can stop the Twitch stream. Yeah, I could do that. I mean, I don't understand what's making it go down. And now it's fine. Nope, no, it dropped again. Can I change the bit rate on the fly? Let me see if it will allow me to. No, I can't. Output, streaming. I have the bit rate at 10,000. Let me change it to 5,000. Let's see if that works. All right, so I dropped the bitrate down to 5,000, and to see if that helps. That should be more stable, I would think. Yeah, because it's been working the whole time, right? Super annoying. I'm really sorry, guys. So hopefully that actually fixes it for a little bit. Still glitching. Great. Interesting. But I have half and half. It's just so strange. Okay, well, let me just stop the stream for a second. I'll restart it and see if that helps. I'll be right back. Okay, I just restarted the stream. I'm back. See if that's working better. I want to get this piece removed here while we're kind of hoping that everything's fixed. Just stopping and restarting it hopefully fixed it. Now, the bit rate's not as high, so it's not going to be as clear. But I need to get this piece taken off. We need to get this replaced so we can put the new chip on here, whatever it is. So it controls the fans, I'm assuming, or gives the power to the fans, or reads the fans. Got that off. Looks like it might be better now. No issues. Okay. So we have that off of there. I forgot to put my oxygen on. But we have that chip removed. I'm going to add some fresh solder. And some flux. We're going to use NF flux all night. Try whacking the bitrate back up. Okay. Yeah, because it looks stable now. So I'm going to change the bitrate back up to the 10,000 and see how that goes. Because 5,000 is kind of low. All right, we're back to 10. We can go to 7 or 8 if it's not working still, but we'll see how that goes. I don't have any drop frames yet. There's some drop frames. Drop frames. Drop frames. Drop frame. 83 drop frames, so we dropped a few already. Still no lag. Yep. Twitch is working fine. Twitch is steady with our 33 viewers. We're at 800 on YouTube. Still have a little bit of drop frames, buffering, lag. Yeah, I'm going to put it down again. We're going to go back down to 7,000 maybe. See if that's better. So back down to 7,000. Yeah, we'll switch to standard definition. That would be perfect. So we're doing 1080p 30 at 10,000 kilobits. All right, so I have the new chip. I'm just transferring it over. Hopefully you guys can see this and you're alive and well with me. Otherwise, I'm talking to nobody. All right, got that installed. Still have some drop frames I see, but not too much. YouTube chat is lagging for you. Oh, yeah, man. Tell me about it. Frustrating. I don't know what we're going to do, what we're going to have to do here. Let me clean this up. Reload YouTube again. Let me do that one more time. Hold on. I'll be right back. All right, so I reconnected the YouTube stream again. We're down to 7K, 7,000 instead of 10. But the 5,000 seemed to be working fine, so I feel like that's what we should be actually sitting at, but we're going to run it at this for a little bit longer. I'm going to keep working at the same time. So we just replaced this chip. This is what I think powers the fans, and we did see some physical damage, so hopefully this is going to fix it up. Now that we have that component, whatever it is, replaced, now we can actually hook the fans back up and the heatsink and all that good stuff. It's interesting that only some people are having issues. Very strange. Maybe if you're watching not live, like on the Cutting Edge live, because even that stream that we had an issue with a couple weeks ago where we had to kind of stop and restart, if you rewatched it, there was no lagginess on the DVR portion of it. So I don't know if it's the way that YouTube is delivering it, but we have 0 drop frames so far since I restarted the stream, so I think we should be good. Where'd my heatsink go? Oh, it's right here. All right, so I think we are good. We fixed that. We actually have 34 people on Twitch watching, which is exciting. And we're at 823 on YouTube. So what I'm doing here is I'm putting some heatsink compound on this heatsink. We've changed out that component that I think is going to resolve our fans not working issue. And we will reassemble, and then we can plug our fans in, run the test. Hopefully that fixes it up, and that will be numero deux, number 2 that we fixed. Yep, looks like it's staying solid. No drop frames. You've had YouTube replays freeze recently. Interesting. All right, got the fans. Let's plug them in. Which way do these fans go? Does I go there? Yep. I am continuing, yes. I will try to do my best if there is more issues. Actually, I can stop the poll because it's 50% of the people said it was not having an issue, and then we restarted, and I'm not seeing an issue on my side anymore. 0 drop frames still, so hopefully 7,000 is going to be a good enough bit rate, because the 10,000 is usually what I'm sitting at, but we can only do what we can do, right? And I will have to yell at my provider. Okay. All right, fans are kind of screwed in. Get that out of the way. They're plugged in, heatsink, thermal paste. We can reconnect the battery, I guess. Get in your home, battery connector. There we go. Yeah, the problem with 7,000 bitrate is I think it's just not high enough resolution or sharp enough, especially when we're doing stuff that's kind of fine and small. So that's the only thing I think about. Let's see if the fans are working now. I hear a fan. Let's see. Let's see if I can take this off of here. Oh, sorry. Oh my gosh, it just beeped at us. Let me try that again. We're going to go into diagnostics. That was funny. Was that beep really loud? Because it was loud for me. I'm sorry, so sorry. I did not expect it to do that. I'm going to hold my mic back. I just wanted you to be able to hear the fan test. Buffering. 57 drop frames, so we did... Oh, shut up. Gosh. All right, here we go. Fan test. Again, it beeps. Sorry. Okay, I will not do that again. So it did pass the test. The fans are working. I will next time just open it up instead. I'm so sorry about that beeping. Hopefully no one's listening to it in their headset. We're going to do an extended test on the CPU. I'm going to close this and we'll flip it over so we can look at it. See if it starts running. Usually it stays on whenever I do this. Oh, I'm running a CPU stress test, not the fan test. Oh, but there you go. The fan's spinning. There you go. The fans are spinning. All right. I saved another laptop. Number 2. All right, so that's 2 of them. So we don't, what do we need to do? Do we need to do another one? Oh yeah, I just added memberships on YouTube, so you can actually join, become part of the team and start basically, help donating to the channel. And so the first tier is called the Coolest Fans. So that's what made me think of that just now. But we got this working, so that one is done. And so the last one, or we can go back to the other motherboard. What time is it? It's almost 8. Whew, it's almost, we've been doing this for about 2 hours. Or we can just chat for a little bit, too. What was the third laptop again? I can't even remember at this point. So we fixed the Alienware M15R2 with the pop and smoke, and we fixed the fans not spinning. So the last one is the Inspiron 3530 with no power at all. Or we can go back to DIY Dave's motherboard. So let's do a poll. Yeah, I think Dave's would be kind of cool if I could figure it out, but all right, and then the last, just chat. So we'll do that, and then let me get a poll up for you on Twitch. I'm having the multitask here. Okay, so we'll see how that goes. So Dave's story is Dave sent in a motherboard, and he was working on it. Where would it go? This one. And he had issues with it, so he sent it in so I could mess around with it. He actually called in at the starting of the stream. You can go back and watch that. Kind of explain what he was going through and trying to figure out. We were trying to figure out how we can get this thing to turn on, and then we noticed that there was a burnt dual diode. We took that off and replaced it with a fuse because I couldn't find a double diode. And then we kind of are just messing around. We messed around with it for a while while we were voting, and then we went to the actual machines that we worked on. So that's the story on that. Hey, thanks for the follows, everyone. And then I always reiterate, so any donations to the stream go to the people's laptops we worked on. I don't keep a dime of it, just to let you know. So anything that you're donating will go towards those repairs and comes off of their repair prices. So so we're looking at the votes. DIY Dave is winning at 56%. And then on Twitch, we have the Inspiron with no power is winning at 50%, and DIY Dave's at 44%. Oh, DIY Dave's is coming up fast. It's at 44, and now it's tied. So this is DIY Dave's board. We can work on it more. You know, probably a low probability of being able to fix it since we don't have a full machine, but we're just going to kind of mess around with it. It looks like it's winning on Twitch also, so I think that this is going to be the next thing we're going to work on. I don't know how much gas I have left in my tank because I have been here for more than 12 hours and I'm getting kind of tired, and you can tell that I get delirious after a little while and I can't speak, and or I start speaking really fast. But it does look like 60% says DIY Dave, perfect. And then 56% on YouTube. So DIY Dave, 1 on Twitch and 1 on YouTube. So that's what we are going for. So we're going to continue working on this machine. So where we left off was when this came in, it had, so this is the power management chip. When it came in, we saw that this resistor was soldered kind of strange. Dave apologized for it, but we resoldered it. And then this is a double diode. It actually has a connector to here and a connector to here, and it's supposed to be a one-way circuit. So we have 20 volts coming through here. I just soldered this fuse on here because we just needed voltage to pass through to get into this power management chip. And this is a 95522H, which I can't remember what the exact voltages we're supposed to have here, but I was pretty sure that we were supposed to have 5 volts here, 20 volts there, 5 volts there. So we're going to have to kind of look around there to figure that out. But we want to see if we have any other blown components around here. And Dave, did you... Why was that resistor taken off? You replaced the resistor because it was blown. That's what you said, right? And so this power management chip was blown and the resistor was blown. Is that correct? 17 volts, or pin 17 is VDD. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is VDD right here. Is that correct? Based on my counting, if my counting's working still tonight. Right. Okay. Let me plug in the power. So what we were doing after we put that fuse on there, we weren't getting any. We were getting voltage to the chip, but we weren't getting our VDD, and we weren't getting the main power rail to be present. So if I measure here, we should have 20 volts here now. We do. And if we measure here, 2.5 is not VDD. We should have 5 volts there. No, the resistor. Here? No, wait. No, because pin 17, this is, how many pins are on each side? We got 8 on each side, so 8, 16, 17. So this should be 17 right here. That should be 17, right? Am I counting this wrong? Am I backwards? Because we have 8 pins on each side. Or am I supposed to be going this way? Is my brain completely broken? Because it would be that one. But this is, it should be this way. We're only getting 2.5. 17 is the first on the right. Let me see if I have a board view for this darn thing. What is this board? I doubt I would have a board view for this. K0. Give me a second. I'm going to hunt for a second. K032P. Just give me a moment. All right, I do. All right. Okay, let's see if that loads. Hopefully it loads. It does. All right, let's switch views. See what we have. Let me see what you guys are seeing. Got that. I don't know if you need these other views on, so I'll turn that off. So here's what we're looking at. So here's our power management chip right here. And yeah, this is what I thought VDD was. That's what it normally is. So we should have our 20 volts here, and then we should have 5 volts here, but we're not getting 5 volts there. Which usually means if we're not getting 5 volts here, either this is shorted, or this pin is shorted, or this chip is bad. That's usually the two things that I've seen cause that issue. So if we go back to our board and look at it, so I'm going to plug in the power again. I just want to show you, because I measured this earlier, because that's the pin that I thought was going to be VDD in the first place. So 20 volts is here on this pin, and I'm measuring 20 volts. And then this pin right here goes to this resistor, and we got 0. We got 0. 0, 0, right? So, and then it's tying across there. Let's measure what these resistors are measuring at. See if we have a short or anything on here. There's no short. And what is this resistor supposed to be valued at? I'm not saying 100K in circuit. I'm saying 60K in circuit. So this one's saying it's supposed to be, this thing doesn't tell me anything. Interesting. Usually I should have more information in here. I didn't grab the schematic. This is just a board view. But we're producing it here. This is a voltage divider. Some sort. What is this? ACLN. And then it ties back here. VDD charge. It's like I have to relearn because each board's different, you know. It's funny, and you know, if I was working on all machines, I would hate to do that because you have to kind of figure it out. If you don't mind, I'm going to reflow this just in case. Make sure we have that. I mean, it looks good, but let me just reflow that just to make sure that that is set down properly, and then we're going to maybe even change it out just for fun, but. I don't know what these measurements are saying, but if VDD is missing, then it usually means that we have some sort of issue with that chip. Or I've seen a short on that output. That's it. Those are the only two things I've usually seen. So. And I'm using the lotion flux. NF lotion. So I'm just going to try to tap this and see if I can get this thing to set in the right position. And it looks like it is set good enough. And we'll let that dry, or cool off rather. What temperature and flow rate am I using? I'm using 450C at 60% for the most times. That's what I usually use. If it's blowing too hard, then I usually would go down to like 45. And so I have a couple settings preset on here. I usually use 300 at 60, 400 at 45, I think, and then 450 at 60%. Just going to clean that up a little bit. Okay, we'll plug the board back in. Let's see if anything changes. Still pulling no current. So the fun thing to do is just to inject 5 volts there, and so we may just do that just for fun. So we got 20 volts, and then right here we got 5.3 now. We have our 5 volts now after I reflowed the chip. Interesting, huh? Interesting. And 1.4 there. What is this? 1.4. I don't even know what that 1.4 is supposed to be. And what do we have? This diode would probably, this is probably coming from the battery, I bet. So this is probably battery voltage, and that's AC adapter voltage. So for that double diode. So let me see if these other power rails are coming up then. Let's see if we have a voltage going out. So we have our main 20 volt power rail now. So you did have the 20 volt power rail before, Dave? This seems like it should be running on like 12.6 volts. I don't see why it would have 20 volts in the main, but it's kind of strange. But reflowing the power management chip turned it on. Now, let's see if it should power on its own. This type of board will power on its own, I think. Let's see. Yeah, so we have, this is the EC chip here, and most of the time these are programmed by the BIOS, so it should turn on by itself when we plug it in, which it didn't. But we are seeing that we are getting the main 19 volts. That seems strange. Okay. So this one, what power rail is this? I have no idea what power rail this is. I have no idea which this one is either. What's this one? 0.8? Oh, the 0.8, the 1.8, or the 0.18 power rail is present. That's a pretty cool power rail to have. So do we have an issue in this area? Now I'm joking, of course, because there should not be a 0.18 power rail. Let me see what thermals are saying. Well, we're not having any thermals because we're not pulling any current, but that's the thing. It's like the thermal camera only works if we're getting current being pulled, but if you look, you can see that there's 0 current being pulled. It's at 0, 0. So, and let me see where the power button is to trigger it on. Heating underneath the, reheating to trigger the MOSFET. I mean, I could just trigger the MOSFET by jumping it too. What about this guy here? There's a little damage on the corner of that. Little chunk taken out. Still have a lot of this lotion all over this. Let me clean this lotion off. Look at all that lotion. Now, of course, this isn't lotion. This is flux. It just smells like lotion when I cook it. And I didn't even put any flux over here. I was working way over here, but it got all over the place. Find a proper diode. Yeah, it doesn't matter. So we've kind of, me and Dave just kind of talked through it ourselves, but the this right here splits the battery and the AC adapter, right? So when we're coming in through the charger, we're going to come in through here, and then we'll energize this area. Diode, right? One way valve. And then on this one, if we're coming through battery, we're going to come in through here and go through there. So it doesn't matter. Yes, it's NF flux. So the new Northridge fixed flux smells just like lotion when it burns. So it does smell like something. He says it doesn't smell like anything. It smells like lotion. And maybe people like the burning smell of lotion. Okay. Let me measure some of these diodes while we're cruising around. So I'm just going to go in continuity mode here. We're just going to see if any of these are shorted. Shorted on. or shorted to the gate. So gate and drain are shorted on this one, and that one's fine. So this one may be bad, but we don't know. That could be some sort of, it could be whatever that's connected to. So we'll keep an eye on that one. What about this one? That one's fine. So that could be our culprit because we were getting 0.18 volts on here, which is awesome. A great voltage to have. Everyone wants 0.18 volt power rail. Measure this one. That one's fine. This one. So we'll measure across, and then we measure these two. Like that. Everything's fine. If it beats really fast, it's not a big deal. It's just filling up a capacitor. This is that one with that little chunk here. I think it's okay though. And then this is the one that Dave said he thought was shorted. So we measure across, I'm not getting a short. Measure to here, we do have a short. And then measure to here, we don't have a short. So it could be measured, it could be shorted across there. And this one's shorted across this way. So that is interesting, very interesting. So this is, I believe this is ground. This is a ground plane. Yeah, so this is the ground plane. So we have this shorting this to ground, but I thought we measured this as not being ground. It's measured at 2 point. That's interesting. So I measure across here. I'm getting 2 ohms across it. Okay, so I was thinking 0, but this is getting 2 ohms across this. But what's tricky is it's not really across that. You have to think about it. You got to think about it. So let me kind of explain what I mean. So it's tricking me in my brain because I'm tired, but come on, brightness. What's going on here? Why did it get so dark? Oh, because I turned my exposure. Sorry about that. Okay. So we have to think about this. So I was basically saying that this MOSFET right here is shorted because if I measure across it, it's measuring shorted. Well, this side's ground, and this side is connected to the CPU. And so if I'm measuring from the CPU to ground or through the CPU, then I'm measuring the CPU because it's basically like if I'm putting my probe if I'm putting my probe right here on ground, and then measuring this coil, then I'm measuring 0.22, right? Well, if this backside of this MOSFET is ground also, so if I measure from here to here, it's 0, then it's basically a false positive. You'd think that that MOSFET's shorted, but it's actually going through the CPU that's giving the measurement. So anyway, yeah, source to drain, of course, duh. So these two. Was it this one? And that's not measuring shorted anymore? Didn't we measure that? Or is it this one? Yeah, it was this one. And this one's fine. Oops, I keep slipping. Camera, move the camera. Someone, do it, please. I'm going to work on something that the mods can actually change my camera. I think I figured out how to do it with StreamerBot, where the mods can actually switch it for me. Because whenever it gets late like this, I forget. Okay, so what I was measuring was this to that, this to that, this to that, this to that. So I definitely want to change that guy out, and this was the other one that looked weird, right? Was it this one? And so that's at 4 ohms. So I don't know for sure on that one. But this one for sure, because it's also giving us a weird voltage. But it's low enough for it to be definitely something. So a B20N03. 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 This is always the fun hunt. If you don't have the exact board, you're like hunting and hunting and hunting. and it gets old. Yeah, I'm gonna switch the feeds with StreamerBot, and I can add commands that will run my OBS. So I think that should work. It'll be monitoring chat, and if you're a mod, and I'll have it where it can run it. So this is the B12 N03. That's a B20 N03. I believe that should work. Can someone look that up for me? B12 N03 versus B20 N03. I believe they're both going to be the same because they're even numbers. So someone look that up for me, please. And I'm just going to take this guy off anyway because I want to figure out if it's having the same measurement when we take it off the board. Update the title, thank you. Dell DIY Dave? Did we turn you into a Dell? Dude, you got a Dell. All right. B12N03 isn't coming up very much, huh? So B20, was it an N channel or a P channel? Seems like it'd be an N channel. It's a lot of residue, yeah. I got the ultrasonic cleaner all clean right now. We'll throw it in there and make it brand new in a few minutes. Okay, got that guy off. So when we take it off, I want to measure those two pins and see if they're still showing that shorted. So it's not shorted here anymore. And then we can test the MOSFET itself. A B12N03 is an N, and then are they both N's? What about the N20? 12 amp. I think we're okay. It's funny, it's not showing shorted anymore. It's hard to measure these things though when they're on the desk like this. Of course, well, here, let's just try to trigger it. We'll put it in diode mode. Here, I'll turn off this loud vacuum here. Dual MOSFET. This is a single right here. All right. So I'm in diode mode. Touch here, it's on. Touch here, it's still on. If I touch here, on. If I touch here, it's off. Oh my gosh, it flew away. And now it's working fine. So it's on. I mean, it's off right now, and it's measuring fine. And the moment I touch this pin, now it's on again. And if I touch it here, that's off again. So this MOSFET's actually working fine. So why is it triggering when it's hooked up here or when it's in circuit? I don't know. I always have this issue because I've seen this tons of times that it will trigger when it's in circuit like that, and I'll replace it and it's not going to fix anything. I don't know what's controlling that. Is it going to be the power management chip that controls that? Let's see if I measure right here. Let's just measure. I guess we can go to the, we'll just go to the board view. I don't know why I'm doing that. So we want to figure out what's controlling that pin right there. And it's this pin right here. So if I'm seeing it doing that, I usually just place the power management chip. That is also tied, wait, no, it's this one. Sorry, that pin. So it's going to be this right here that's controlling that the gate on that MOSFET. And if it's showing that these two are connected while it's here, then it means that this thing is somehow pulling it high and turning this on. No, because it would turn the whole thing on. So I don't know why those things are, it's saying that these two are connected, basically. Anyway, I tend to want to change that out. Change out the power management chip when it does this, because you're sitting here chasing your tail, and it's a lot easier to eliminate different problems by doing that. So that's probably what I want to do. That or go to sleep. But we did start getting our voltage there, which is funny. And we did we conclusively say we can change that out? We have a threshold, 40 amp threshold. N20, wait, so yeah, the N20 is an N channel. So they're both N channel. And just one is a 12 amp, and the other one's a 20 amp maybe? 40 amp. Is there a solder ball under it or something? I mean, it could be, but it's not measuring shorted like right now. So that's the thing I was talking about. So like if we have it out of circuit now, and that measure across here, it's not shorted. We're getting 97 ohms, which might be too much. Yeah, tune in next week for DIY Dave's part 2. Yeah. I tell you what, we could just do, we could change this power management chip out. Because I think I just want to put this MOSFET back on because it is working. I'd say put this MOSFET back on because it is working, because we're able to trigger it on and off, so it is working. So let's just change the power management chip out, put this MOSFET back on, and see what it does. And then call it for the night, I think, because I'm tired. I mean, yeah, I've been here for 13 hours, and I'm just like starting to get a little bit delirious. Ugh. Let me stretch. Let me take a drink of water for round 2 here. N03 ID 40. Yeah, it should vote to sleep. Let's see. I'll put up a vote. Every time I put a vote up whether I should quit or keep working, people are always like, keep working. So I hate to do those votes, because if this is a choose your own adventure and I have to follow what you vote for, it's not a good, because I would never sleep apparently. Now, if there's a vote to go home and have a bourbon or go to sleep, then you only have 50-50 chance on that. Okay, do I have these chips? That's the question. So 95522H. Let's check my arsenal here. Let's see if we have focus on everything. Go drinking, yeah. So 95522A. There we go. Boom. We have it. Okay, I'll just do these last 2 things. We'll just, you know, we got to give them what they want. Because if we can get a 3-fer tonight, right? We've already fixed 2 laptops. Now, if we can fix a board that doesn't have anything that went with it, or at least get a little bit, we actually got the main power rail to come up, right? And if we can get this other power rail that's measuring at 0.18 actually showing what it's supposed to have, that would be pretty nice too. You know, Dave could have sent me a spare board, but you know what I also could have done? I could have went and grabbed a spare board somewhere earlier in the stream, like, or before the stream started. I was really busy though earlier. I've been working on laptops all day and trying to finish stuff up. I was working on the laptop from last week with the board, the bad CPU. Oh, and all the donations from last week. You know, we had 2 different repairs last week that the donations would go to. Well, one of the guys, the 9710, where we fixed his machine, he donated all his money to the other fella because he was disabled and you know, we wanted to pay it forward to him. So I thought that was a great gesture that he did. So we got $110 in YouTube donations from last week's stream that went straight to the customer. So that's awesome. And so I'm getting him a new board. I actually have a new board installed into this laptop right now. All right, back under the microscope. So these are the 2 chips we're going to be installing. So I'm going to pre-tin this. We will put a little bit of this lotion on here. I wonder what it feels like to rub it on my skin. Let me get my air. Oh, you missed the live stream last week? Well, you can rewatch it. It's 4 hours long, so watch it in parts. But it's kind of cool. Just put it on in the background, you know. I feel like that's what a lot of people end up doing is just put the live streams on in the background, and you can kind of still have some entertainment out of it. We actually did 3 last week, I think. Or maybe we only did 2. I can't remember how we did. We were here for 4 hours doing it, so that's all I know. So I'm just going to put a little bit of solder on here, and I'm just going to try to pre-tin these pads on the edges. That's my main goal, or main concern. And this allows the it makes it so I don't need as much solder on the board itself. Otherwise, we won't have enough. And we can just tap the middle just a little bit, not too long, because I don't want to suck up too much on there. There we go. Oh, that's not what I wanted. Okay, well, we got a little too much in there. This one we don't really need to do anything to. Let me take the old one off. I'm going to turn this around. There's these connectors here, and I don't want to melt them, so I'm just going to face the board the opposite direction so I can blow the air away. Go that way. A little bit of lotion. Preheat the board just a little bit. So right as the pins start getting shiny, we can lift it right off. Boom. So I'm going to set it off to the side. I'm not going to throw it away or anything. We're just going to set it off to the side because we don't know if it's going to do exactly the same thing. And you see some of these pins are on the back side are touching. It doesn't really matter because once we put the solder and flux in there, they're going to do what they want to do, which is adhere to the pin layout that's on the board. If I can get this sticky stuff off of here. For lotion, this is pretty sticky stuff. All right, so pin 1 is here. I'm trying to get it oriented so we can get pin 1. I can't really see it. I can't tell which way is what. Okay, keep spinning, I guess. I have no idea. I can't see it. Can anybody else see it? I think it's right this way. I think that's it. Okay. There we go. Going in, coming in hot. Coming in hot. Okay, we have way too much. I don't really care. So what we're doing is tacking it to the board first. We'll heat it up, press it down, squeeze out the extra. Ooh, look how pretty that is. Should I leave it like that? No, that's not what we're gonna do. I'm just trying to squeeze out the extra, and then we will Add some more of this stuff on there. We'll suck up all the extra stuff that came out the sides. Like that. And then we can reflow it one more time to get it to sit down exactly right. Okay, there we go, that's good. And then let's make sure our awesome fuse, our calibrated fuse is sitting in the right position. So our calibrated fuse is still there. And then we need to put that MOSFET back on, wherever it went. Here it is. Okay. So again, I'm just tacking it for a second, add some flux, reflow it, and see how it just kind of jumps where it wants to go, and that's where it's supposed to be. The end. Okay. Whew. Oh, so this is going to work or it's not? I don't know. I'm going to clean it up a little bit because that's what I do. Great sorter balls, Batman. That's nice. That's a good one. It's a nice one. Oh, the shirt of the week. I have this linked inside the video description if you're interested. Just kind of lists all the different things that I do. Let's go ahead and do all the different things. So you can snag one of those. Link in the video description. Okay, so that is done. Let's measure. So I want to measure these two again. So we have no short there. We have no short there. No short there. So let's plug it in, power it on. Should we do it under the thermal camera or not? I don't know. I don't know. Oh yeah, we'll do it under the mixed view here. So we have the thermal camera and the regular view. We'll do it like that. There we go. No chat, but you get extra cameras. All right, so keep an eye on the power meter. Right now it's still hot from whenever I just soldered, but we want to see the board come on automatically right when we plug this in. 3, 2, 1. Still nothing. Still nothing. Let's see what we're measuring over here now. Nothing, nothing, and then this is the one that 0.19, the same 0.18 is what we had before. So I'm not sure. I'm still not sure exactly what's causing this issue in this area. The gate pin, you see how our gate pin here, if I measure that, we're getting 0.18, and then our output, we're getting 0.18. It's like those are bonded together somehow. So I don't get it. And I've seen this before on other machines when I'm working on them, and I just never was able to figure it out. So I'll have to kind of think about it, what's causing it. So it's like, because I guarantee now that I measure this, it's going to be shorted across there. So I come back, and then this is going to be measured shorted. See? So I don't know. I don't know right now. And I definitely can't think that well. So at this point, we're going to bench this. But we did make an effort at it. We got a little bit further on it, and we were able to fix 2 machines. Hope everybody enjoyed themselves tonight. We were streaming for about 2.5 hours tonight. A little shorter stream tonight because I am a little extra tired, but and then next week's also going to be a short stream. We're only going to stream for 2 hours next week because I have some stuff going on that night. But it's going to be bourbon time for me. I want to thank all of our Twitch viewers. Welcome aboard. So every single Wednesday night, 6 p.m. Central Time, I do a live stream. It's always going to be or most of the time what we've been doing is going to be a choose your own adventure. I put up a list of laptops. Everyone votes on it. I don't look at these laptops ahead of time. I have no idea what's wrong with them. Everybody kind of votes on it, tells me what machine they want to see me fix live. I just kind of figure it out as I go along. I specialize only in Dell and Alienware laptops, and that's the only thing that I work on. And I've been doing it for about 25 years. So that's kind of the gist of that. So follow, subscribe, do all that fun stuff. Support the channel. You can buy the t-shirt. Any donations going into the stream, I don't keep any of it. It goes straight to these people's laptops. I want to thank DIY Dave and JFix. Both of them are our moderators. And I want to thank everybody for tuning in tonight, and I'll see you next week. Thanks for watching.
I saved another laptop.